Let's go inside. Let's go inside the triangle now and start talking about all the different types of angles inside. First thing, and this is something you've known for a while. We just haven't, you probably never put a name to it. The triangle angle sum theorem, which basically says all interior angles of a triangle add to what? Buck 80. So that's what this, we're just going to give it a name now, which is the triangle angle sum theorem. So all interior angles of a triangle add to 180. Three angles of a triangle, 2x, x plus 10, and 3x minus 10. Find x. Going to ask somebody, set up an equation for me. Those are three angles inside a triangle. 2x, x plus 10, and 3x minus 10. Give me an equation that I can set up here. Let's go, 26. Give me an equation. Got it. Add up all three angles, set them equal to 180. And when you're ready, let me know the value of x. 1, go ahead. 30, yep. Nice job. Find the degree measures of each of the angles now. So take 30, plug it into 2x, x plus 10, and 3x minus 10. And when you're ready, let me know the angle measures. 12, when you're ready, let me know the angle measures. 60, 40, 80 degrees. Yep, quick check. Yes, they all add up to 180 degrees. All right, name the type of triangle then. This is going back to yesterday. If you need to go back a couple pages, please do so. If I have angles 60, 40, and 80, how can I name this triangle on its angle? So don't tell me isosceles, scalene, equilateral. By its angles only. What could I name this triangle? Here you go, 19. What could I name it? It is acute. All three angles are less than 90, so this could be an acute triangle. Any questions there? Go in. All right, now next one you'll notice no diagram provided, correct? So we're going to have to do our best to draw our own. So I have triangle ABC, and again, it does not matter the order you label. These are called vertices, where you put A, B, and C, vertices. Angle A is 40, so put angle A, 40 degrees, put a little 40 in there. C is 30, got it? And then I'm going to draw a segment CD in, right? CD, so I'm going to start from C, go over to the opposite side, and draw a D in. Doesn't matter where it goes. And what's CD doing? Bisecting angle C. So I started at 30 degrees. Name two angles that are congruent up here. 19 again. Name two angles that are congruent. Perfect. ACD, BCD are congruent to each other. Definition of a bisector. Meaning if that whole angle was 30, what's going to be each piece. 17, what's each piece here? 15 degrees, got it. Everybody good? Haven't lost anybody yet? Okay, find angle B. Find angle B. You already know 2 out of the 3 angles of triangle ABC. You have 40. You have the 30-degree angle, and now I'm looking for angle B, which is the missing angle of the 3. 13, when you're ready, what do you have there? I got 40, 30, and 110 degrees. Yep. 180 degrees in all triangles. Any questions on where 110 came from? What about ACD now? Oh, I guess we answered that, and that was 15. That's definition of a bisector. ADC. ADC. Now, hey, there's 3 different triangles in this diagram. Doesn't matter if one's inside of another. What are all their interior angles going to add up to? 180, 180, 180. All right, doesn't matter if one's inside another. So I have 40, I have 15. What's left over to give me 180 degrees? 20, what's left over? 125, 125 degrees. Okay, BDC. Take a look at that angle, everybody. BDC. Now, here's the problem. You can't use 180 degrees in a triangle because I just know 15 degrees. I don't know any of the other 2. So I'm going to have to use some other geometrical method here to find that angle BDC because I can't have it in a triangle. Oh, okay. You found angle B. You got me there. I was hoping you guys used something else, though, but that's fine. What do we call these here? I was hoping you used this. Linear pairs. What do you know about them? Supplementary, and I guess you could have subtracted them from 182, and it came out to be 55 degrees. Anything from you guys? Okay, I got one more here. One more. And can you guys do me a favor? Can you please make this a ratio of 2 to 7, not 2 to 5? 2 to 7, not 2 to 5. Appreciate it. Already is, and I just have an old copy, huh? Well, I should keep it 2 to 7. Okay. So I have triangle ABC. Angle C is 72. We've done a couple of these so far this year. What have we been doing if we have anything that's in a ratio? Putting x with them. So 2x will be angle A, angle B, 7x. Equation for me to solve so I can find x. Here you go, 27. Equation for me to solve to find x. You got it. And when you're ready, the value of x. Here you go, 5. X equals 12, yep. So x equals 12, but it said find the measure of each angle. So go back. We already know angle C, so I'm not going to ask that. So what about angle A and angle B now? Take your 12, plug it back in for angle A and B. And let me know here. Here we go, 19, let me know. Got it. And angle A? 24 and 84, good. Questions? We're done with inside the triangle. Now we're going to find the angles outside, aka exterior angles now. Any issues with the interiors? Okay, let's come up with a little, see if we see any patterns here with the exterior angles. All right, exterior angles on the outside of the triangle. So I need somebody right now using this beautiful diagram, triangle ABC. Can you name an exterior angle for me right now? Name an angle that's on the outside there that I've already labeled. Name an angle on the outside of the triangle. Here you go. 28. Name an angle on the outside. Angle 1. You're darn right. Angle 1. Perfect. Nice job. Now, what I'd like to know is what's its adjacent interior angle. So the angle that's next to it, adjacent, but inside the triangle. All right. So angle 1, what would be its interior adjacent angle? 22. Angle, lowercase a. And what would be the non-adjacent interior angle? So the one that's not next to angle 1, 21. How about 30? And? Is that it?
Wait, angle C.
Angle B and angle lowercase c, yes. Now, hey, I'm not, it gets too wordy here. I'm not going to refer to them as the non-adjacent interior angles anymore. I like to refer to them as what I have in parentheses underneath, and that is those are the remote interior angles. All right? Yes, you can still refer to them as the non-adjacent interior angles, but I'm going to start calling them the remote interiors. Okay, give me another exterior angle. 5, give me another exterior angle.
2.
Angle 2, there we go. So if I go angle 2, what's my adjacent interior angle? Here you go, 20, what's my adjacent interior? Angle lowercase b. And then what would make my remote interiors here? 2. Angle A and angle C. And can we just fill in the other one here? Angle 3. Angle C. And BN A. Okay. There is a special relationship between the exterior and the interiors here, but I'm not giving it to you. You are going to help me find it. Okay, let's go to the backboard. Have your calculators ready to go. You do not need to copy this down. I just need your help. I think 3 should do it, I hope. Okay, I need your help finding all the remaining angles in these 3 diagrams. Can you do that for me? Okay, let's start with number 1 here, 100. What's another one you can find for me? 80, where? Adjacent to it, all right, let's keep going. Can you find the missing angle here for me? What's my missing angle over there? How much? 50? That's 56 up here. 40. Got it. 20 right next to it. Okay, that's not going to work, is it? Let me switch it. 160, that'll be 20. Missing angle. 1, let's see, what is that? 2, that's 102, so that'll be up 78. Okay, and up here, buck 30, yep. Here's what I want you to focus on. The exterior angle of each of these. And see if it relates to any two angles inside the triangle. Look at my exterior angle for each of them and see if it relates to any of the two interior angles at all. Don't say, you can discuss it amongst each other if you want, but there is a relationship between the exterior and two of the interior angles up there. What is it? $50. How can I get 50 here? 30 and 20. How can I get 160? 78 and 82. How do I get 100? 56 plus 44. So what you're telling me is the following. An exterior angle is always equal to the two, what are we calling these? Remote interior angles added up. Everyone agree? And that will always be the case. Any exterior angle will always be equal to the sum of the two remote interior angles added up. All right, so let's put it down on paper now, our theorem, which says an exterior angle is equal to the sum of the, what are we calling those two angles? Yeah, remote interior angles. Ooh, this is a lot of people in the way here, going at a different angle than straight on. There's little wind, though. Could be to my advantage. Ooh, this is a lot of this narrow space here. I'm predicting I'm just going to whiff totally. Oh, yeah, whiff totally. Get that back here. Get that back. I can't. That's embarrassing right there. That's embarrassing. This is it. Then I got to go back to teaching. That was embarrassing. Get it. Right there. All right, let's go. I'm done. I'm done. Okay, finding the number of degrees and the value of x. Now, yes, I realize that, yes, we could do 40, 90, subtract it from 180, get the last interior angle, and then get the exterior. I get that, but I want to get there right away. We just learned a theorem that said what? This exterior angle x should be equal to the sum of, what are the two remote interiors here? 40 and 90. So real quickly now, we could end up with 130. Again, do you see the other way I could have gotten there? I could have found the final interior angle, which would have been 50. These are linear pairs, so they're supplementary. It would have gave me 130. Okay, strap on your algebra boots. Here we go. Angle A is x squared minus 6x. Angle B is 2x minus 3. And ACD is 9x plus 27. This is why, yes, we got to know this theorem, because sometimes there'll be variables involved. All right, where's the exterior angle? 9x plus 27. We just had a theorem that said that is equal to, name one remote interior angle. 2x minus 3 plus the other remote interior. X squared minus 6x. Yep. All right. Can we just clean some stuff up before we talk? So 9x plus 27 is equal to, let's see, I'll keep that x squared in front. What do I have as far as the x's go? Minus 4x minus 3. All I did was clean up the right side. All right, everyone see the highest exponent up here? That's a 2. Probably going to have to end up factoring, but not until what? One side is solved for 0. One side is equal to 0. So I'm going to move 9x and 27 over. How? Subtract the 9x and subtract the 27. So I end up with 0 equals x squared. What do I have in the middle here? Minus 12. 13x minus 30. All right. I'm going to expect this out of you. All right. Honors level course. Expect this. And again, we're not doing anything tougher than this. Two numbers that do what? Add to negative 13, but at the same time, multiply to negative 30. I always start with the multiplying. Numbers that multiply to 30 that can possibly give me 13. So I go down, ready? Here we go. I go down the list. I go, let's see, 5 and 6 pop into my head right away. That's not going to give me 13. No chance. So I start thinking 10 and 3. Well, it could, right? 10 and 3 could give me 13, but here's the problem. What's the only way it's going to give you negative 13? If they're both negative, and what's the problem there? If I multiply, that'll give me positive 30. I need a negative 30. So there's a tricky one right there. All right, so I believe there's one more pair I haven't talked about. Negative 15, positive 2. Okay, so I end up with x equals what for an answer here? Positive 15. I don't know why I just did that. So I end up with x equals 15. And on the other side, x equals negative 2. All right, we're going to have this awkward stare until somebody tells me something's not right. Something's not right. Yep. Well, why? You can have a negative answer, but why am I not allowed to have this one in particular? Let's plug in. Ready? Everybody plug in negative 2 to angle B. What's going to end up happening? You're going to get negative 7 degrees. Can't happen. Cannot happen. Now, I can't. Hey, ready? I am not going to reject this answer because it's negative. Why am I rejecting this answer? Because it gives me a negative angle. Okay, please make sure you're aware of that. I'm just not automatically rejecting it because it's negative. Because when I plugged it in, it gave me a negative angle. All right, so we are going to, much like some of the fellas' dating scene coming up, getting it rejected. Okay. Too harsh, fellas? Sorry. I've seen some of the clientele in here. It's not too pretty. All right. You may want to store up my pickup lines for later on. Okay. Questions here on why I'm rejecting the negative 2. Okay, I am going to let you right now in your group do example 4. Oh, sorry, I forgot example 3, huh? Okay, we'll do example 3 together. I didn't notice. Oh, yeah, I skipped over it. Sorry. There it is, example 3. Got it. And then you're going to do example 4 on your own. Okay, triangle PQR. The measure of P is twice the measure of Q. All right, so I should probably call one of them X, right? Suggestion? Q, because P is twice it, so 2X. and there's an exterior angle at R. So here you can draw it out here, going out that way, or you can draw it out coming out that way. It's up to you. I'll draw it out coming out this way. And that has a measure of 120. Find angle Q. 13. 120 is on the outside. What type of angle is that for this triangle? That's an exterior angle. We just learned a theorem. What's any exterior angle in a triangle equal to? Which in this case would be what angles? So 2x plus x. Yep. 3x equals 120. X equals 40. And then go back. What did I need to find? Q, which I called x, so it's 40 degrees. All right. Okay, now this is a great question. This is why I'm going to leave it all to you and your group. Not only does it involve triangle interior and exterior angles, it also involves parallel lines. So I will put the answers up here. If you and your all right. If you and your group get the answers, move on to the homework. If you can't and you're struggling, call me over. I'll give you a little boost.